In this video, we are going to determine the amount of nitrogen that will evaporate at the boiling point of 77 kelvins. So the question says, a 30 grams ice cube at its melting point is dropped into an insulated container of liquid nitrogen. How much nitrogen evaporates if it's at its boiling point of 77 kelvins and has a latent heat of vaporization of
Okay, so the data that have been given here is the mass of ice, which is 30 grams at melting point, then the boiling point of nitrogen, which is 77 kelvins, and latent heat of vaporization, which is 200 kilojoules per kg. How much nitrogen evaporates? So here we're going to consider two important equations, and those are the equations for the heat lost by ice as it melts, and also the heat gain or the heat that is gained by nitrogen. So here, the information that we have is the initial temperature here, which is 0. Okay, so 0 will let us come up with, let's try to evaluate, let's analyze the data here. So we have the mass, which is, let us call it the mass 1, which is 30 grams. Then the temperature, which is 0 degrees Celsius, which is equivalent to 273.15 Kelvin. If we convert to kelvins, and the final temperature of the system that is going to be reached is 77 K. So now let's call the equation, or rather the heat lost by ice as heat 1, and also the heat gained by nitrogen as heat 2. And according to the principle of energy conservation, this must be equal to 0. The heat loss and heat gain must be equal to 0. So let's now write their expressions. So for heat 1, that is the heat lost by ice, we have mc dt, which is the mass of ice times the specific heat capacity of ice and the change in temperature, plus mLV, the mass times the latent heat of vaporization, and this should give us 0. So from here, without even wasting much time, we can say, okay, this is mass 1 and this is mass 2. So without even wasting much time, we can make mass 2, because we are looking for how much nitrogen evaporates. So we are going to make M2, which is the mass for the nitrogen that will evaporate because of this latent heat of vaporization. And this is what we're going to do. So we're going to make it the subject of the formula, and we're going to have, so this is, let's just take it on the other side. We're going to say M1C delta T is equal to negative mLV. So this is M2, and from here we can just divide by negative LV, even here negative LV. So this and this will cancel, and the negative and negative will cancel. What we're going to have is M2 is equal to M1C, then delta T over negative LV. So from here, we're going to proceed now to find the mass. Okay, but before we find the mass, let's see the delta, the change in temperature. So dt is equal to the final temperature, the final temperature of the system will be this. So which is 77 kelvins minus, okay, the initial temperature is 0 degrees Celsius, which is equivalent to 273.15 Kelvin. And then, so from this, we know that it is T, okay, TF minus T initial. This is the T final, this is the T initial. So what we're going to have is 1 96.15 Kelvin. So this is the change in temperature. And then the latent heat of vaporization, which is this, the LV, we have 200 kilojoules per kg. So if we convert this to joules per gram, what we're going to do is, so since this is a kilo, it is a kilo, so we're going to say 200 times a kilo, which is just 1,000. Okay, joules over, so 1 kg times 1,000 grams per kg. So that a kg and a kg will cancel, and this 1,000 and 1,000 will cancel. So what we're going to have is 200 joules per gram. So this is the latent heat of vaporization in grams. So now let us put this and this into this one. In fact, this must be a negative value. It is a negative. This minus this, it is going to give us a negative value. So this is the negative 196.15. So here, let me just erase the top part here. So our M2 will be equal to, the M1 is 30 grams times the specific heat capacity of ice. The specific heat capacity of ice is 2.05 joules per gram per Kelvin, then times the change in T, which is negative 196.15, divided by negative 196.15. So what we're going to get if we punch this on a calculator, what we're going to get is, so this 30 times 2.05 times negative 196.15 divided by 196.15, we are going to get a 60 grams. So this is the amount of nitrogen that will evaporate at 77 kelvins. Thank you so much for watching the video.